Hi everyone, welcome to today's video. If you're new to the channel, please subscribe to the channel. This is much appreciated. Today we'll be looking at the composite design pattern. Now, the composite design pattern is a very useful design pattern, especially when we have tree-like structures, such as maybe like an organizational chart, and we want to perform a particular operation across that organization. So let's say we have our organization and we have the head office, for example, and within our head office we have teams or we have regional offices that report to that particular head office. So for example, we have team 1, we have regional office 1, we have regional office 2 interacting with the head office. We see that team 1 has 32 teams. Also, these regional offices also have teams and regional offices under them. So for example, we see team 2 with 7 staffs under that particular team, and we have some other regional offices 3 to 7. Under this, we could also have some teams and even regional offices under. So we see, for example, the regional office 8 is under the regional office 4. Now, we also have regional office 3 having team 3 and team 4 under it, and some other team 5, for example, is under regional office 5. And then under the regional office 8, for example, we have the team 9, that is T9, with 2 staffs under it. Now, let's say this is what we have, and then we want to, from the head office, we want to know what is the total number of staffs we have within this organization. What we will have to do is to have each team report the number of staffs they have to the regional office they are reporting to. So for example, the team 9 will report to regional office 8 that I have 2 staff. So regional office knows that under me there are only 2 staffs. Now, so we see team 3, team 4, all the way to team 8, and with the regional office 8, they also report to the regional offices to which that is above them in the organizational structure. So for example, the regional office 3 has team 3 and team 4 under it, and so both of them will report their total number of staffs. And so at regional office 3, for example, it knows that it has 10 staffs under it. Also, when we look at regional office 7, it knows that I only have team 8 and team 8 has 9 staffs under it. So regional office 7 knows it has 9 staffs under it. Now, all of these regional offices and teams will report also upward, cascading it upward. So for example, the regional office 1, we have 17 because we have regional office 3, 4, and 5 reporting. While we combine them, 10 plus 2 plus 5, we have a total of 17. When we look at regional office 2 also, is a combination of regional office 6, regional office 7, and team 2. Together they form 14 plus 9, that's 23 plus 7. So we have a total of 30 in regional office 2. Now when we get to the office and want to know the total number of at the head office, all of these regional offices that report to the head office, or the teams that report to the head office, also they will cascade it upward. So for example, the head office we have 79 because of team 1 at the head office has 32 teams, that's 32 staffs. Regional office 1 and 2 have 17 and 30 respectively. So this is how we could implement, because we are doing something similar all across. We're just getting the total number of staffs and cascading it upward. So here we will find the composite design pattern very flexible and useful for us here. Let's look at an example in code. So let's say we have our team and we have our office. We see that, for example, let's pick the team first. We see that within the team, it has the total number of staffs within that team, and it also has the cost per staff. So we pass this through the constructor, so it knows the total number of staffs and it knows the cost per staff. And when we look at it, we see that it's implementing the I company estimate. So if we go to that, the definition, we see that the I company defines 2 methods: the cost per hour, which is going to be used to calculate the cost per hour, while we have the total number of staff, which is used to calculate the total number of staffs at a particular team or office. So basically, if we go back to our team, we see that the cost per hour is just the total staffs, that means the cost per staff. So for example, if the cost per staff is $5 and then we have 5 staffs, it means the cost per hour for that particular team will be $25. And for example, as we said, if the total number of staffs is 5, that means the total number of staffs will be 5 that will be returned. If we look at how the office look like, we see that the office also is implementing the same interface, the I company estimates interface. But what is kind of different here is that we see that the office has an array or list of the I company estimates. What this does is, for example, it allows like for example, we have regional offices having regional offices under them or teams under them. So because the office and the team both implement this interface, it means we can both have offices and teams under here. So I just call it teams offices just for simplicity. And then we have the office hourly cost. So that means for each office, there is a overhead cost for that office to operate. So for example, let's say the cost for electricity bill or cost for maintenance, things like that. So there is that additional cost for having a particular office. So that's what this office hourly cost is. So let's say for example, the hourly cost for an office could be maybe $200. So and that is passing the constructor, or for example, we could pass the hourly cost and then the teams or offices within that particular um office. So also we see here that we implement the cost per hour, but if we see here, we are adding the office hourly cost to the sum of the cost per hour across all the teams or regional offices under it. Now, unlike when we had in the team, we just know that that is the end of it. So it's just going to be the cost of the staff and the cost per staff multiplied by the total number of staff. But for offices, it's going to be the total number, the sum of the cost per hour at each point that is under it. So for example, if for all the offices or the teams under it, it sums them up together. Now, and then we'll have to add that with the cost of running that particular office that we are currently on. Also, we have the total number of staffs implemented here, and that is just the sum of all the total number of staffs under it. So for example, regional office 1 had team and regional office 3, 4, 5 under it. So for example, the total number of staffs in regional office 1 will be the sum of regional office 2, 3, 4, and 5. That's just basically what this is doing here. And then we have this function, the add office, just a way to add offices to our team offices. That's just basically what that does. So if we look at our program.cs, and let's say this is our client here that wants to use our data, we have, for example, we have the head office here, and we see that the head office, the hourly cost for operating the head office is $500 per hour. So if we just look here, this is just the regional office 1, 2, and then team 1. I just basically try to replicate what we tried to show in the hierarchy before we started, before we came to the Visual Studio. So basically we see that regional office 1, the cost for operating it is $200, while the cost of operating the regional office 2 is $150. And we have team 1. Team 1 has 32 staffs, and the cost per staff for that team 1 is $20 per hour. So what we just do is just add these offices and teams. So for example, we add the team 1, we add regional office 1, and we add regional office 2. Same thing we do for the regional office 3 and the team 2. We add all of those together, and then we add the respective regions to their respective regional offices also, to all the way till team 9 added or into the regional office 8 basically. So that's basically what this here is just all about. So here you see, when we want to now get the total cost per hour in the head office, we do not need to go individually to all of them and get it. All we just need to do is to call our cost per hour on the head office. And since this is an office, what this does, it goes into all offices under the head office or teams and gets their respective cost per hour. That is basically what this does. And the same thing with total number of staff. For the total number of staff, it goes into all the regional offices or teams and get the total number of staffs within those regional offices or teams, and then we find there, we just consolidate. So if we run this now, we see that our HR company portal is telling us that the total number of staffs in the company is 79, and then total cost per hour is $2,659. This has kind of simplified for us our logic. So you see, from here we just know that okay, we are calculating the head office cost per hour, and it gives us that very simply and nicely. So tomorrow, if we have another type of structure, so for example, let's say we have outdoor field, and then those are not really under offices and they are not teams, we could just simply go ahead to create a new class for those, and we will make sure that they implement the I company estimate. So let's just go ahead and try something like that. So let's say we wanted to add a new class for that. So we just have the outdoor offices or outdoor field, something like that, I think. And then to this, we just basically implement the interface that we have there. So we have the I company estimate, and then we implement the interfaces there. Yes. So basically here we could just have our private read only, let's just say total staffs, or this is going to be long. Let's just have this, and let's just keep this simple. So we have our constructor, and then let me just pass in a constant value here. Let me just pass in a total staffs and just give this to be 5 here. Let me just make this constant. So here, when we ask for the total cost per hour, let's just say it is the total staffs multiplied by let's say 4. Let's say it's $4 for every hour of staff, and the total number of staffs here will be total number of total staffs. So basically, if we have this now, so for example, if we have such thing like the outdoor field now, all we need to just do is this, and then when we add that to our team, so for example, if we go to our program.cs, let's just say I came here and to our regional office 8, I wanted to add a team, an outdoor field. Let's just, and then I'll pass in, I think, okay, we don't need to pass in anything, and then I could just pass that to our field, pass our field to that, and you see it works seamlessly. My cost per hour will still calculate and get the current value without having to change the implementation for my head office or how the office will implement. It just goes seamlessly, and so when we look at it now, we expect is 84 now, because initially it was 79, and we have hard coded the values for the total staff in that field to be 5. So 5 plus 84 plus 79, sorry, will give us 84. And then the cost per hour also, we see that it had a slight increase there. So we see that this allows us to follow the open close principle properly without having to make changes to how the offices work or how our teams work. We are just able to seamlessly plug in our new kind of layout, which is the outdoor field, to this. I hope we enjoyed this video, and this basically is the composite design pattern. If you enjoyed this video, I encourage us to please like, share, and subscribe. If we have any questions, we can drop in the comment section, and I'll be there seeking to answer us. Thank you, and see you in the next video.